This is a story problem that goes along with our solving systems of linear inequalities. And so you're ordering bricks and sand. You need a minimum of 500 bricks and 10 bags of sand for the project you're working on. Bricks weigh 2 pounds each and sand weighs 50 pounds per bag. The max weight that can be delivered in a truck is 3,000 pounds. And so most of these places that deliver will have a max weight that they can carry. And so you got to order in correspondence with that. Now, it wants you to write and graph a system of linear inequalities that shows how many bricks and bags of sand could be ordered. And so the first thing to look at here, and this is the part that's often forgotten, is know what your variables represent. And so I'm going to have x represent this right here, how many bricks. And I'm going to have y be the number of bags of sand that we have. And so when I write them, I'm going to make sure to keep that in mind. Now, as far as the bricks, I know that a minimum of 500 bricks, and so it's okay to have exactly 500, but I need x to be greater than or equal to 500. So exactly 500 is okay, or I actually need more than 500. Now with the bags of sand, I need at least 10, and so y has to be greater than or equal to 10. The truck is going to have a little bit of each, so it's not just going to have one or the other, and so this is corresponding to how much exactly I need. The truck is more in respect to it can only carry 3,000 pounds. So I'm really looking at this weight stuff here. For every brick that I put on there, it's 2 pounds. So that's 2 times x. That's the weight of my bricks. And so if I get one brick, 2 pounds. As far as the sand goes, it's 50 pounds per bag. So it's going to be plus 50 times y. And then remember, the truck can hold 3,000 pounds, but I don't have to load the truck up to capacity. They can carry less than 3,000, and so it could be less than or equal to the 3,000 there. And so all of these could be equal to what I'm dealing with. And so the lines that I make are all going to end up being solid lines. Now it's important as I go to graph this, it's important to think about what I'm going to want to number my boxes by. And as I look at this, the x-axis has to get all the way to 500. Since it has to get to 500, I need to work fairly quickly there. Now I don't necessarily want to go by 500s because then everything's going to be in this little box here, but I also don't want to go by 10s because if I go by 10s I won't get to 500. So I think what I'm going to go by here, I'm going to go by 50s here. And so each one of those boxes is going to be 50. Now I really only have to put it on this first one. By putting it on the first one, I'm telling you that all of them go by 50. And as far as going up, I see the 10 there, and so as I look at that, I think I'm just going to go by 10s on that y-axis there. So x is greater than or equal to 500. Remember, whenever you have x equals a number, that's going to be a vertical line. And so as I go to graph that, I know this is going to be a vertical line at 500. And so this is 100, 200, 300, 400, 500. And so I'm going to go ahead and make that vertical line right there. And so I know that these solutions, the x's have to be greater than or equal to 500. So I know that all the solutions that are greater than or equal to 500 are somewhere over here. I'm just going to keep that in mind, that this is where the solutions are, is to the right of that line. Now I know that y has to be greater than or equal to 10, so that's actually going to be a horizontal line at 10. And so I make that there. Now, that has to be greater than or equal to 10, so it has to be somewhere up here. And so make sure you kind of know right now where your solutions are. Now, for this last one here, we have to go through and we actually have to solve and get in a slope-intercept form here. So I'm going to want to subtract 2x, and then I'm going to want to rewrite it. So I have 50y is less than or equal to 3,000 minus 2x. Divide by 50. Divide by 50. And so I have y is less than or equal to, and then that comes out to be 60 minus 1/25 x. Now, as far as actually graphing that goes, the 60 is going to be fine. 60, 10, 20, 30, 40, 50, 60. 60 is going to be right here. That's not hard to find. 10, 20, 30, 40, 50, 60. And so as I do that, that's no problem. The minus 1/25 x, that's the part that I have to kind of think about here. I'm going by 10s and by 50s. It's going to be kind of hard to go down, just a little bit and over and be real accurate. One little trick you can do here is, since this is going by tens, instead of being 1, let's think of it as 10. But if we add a 0 to this, we also have to add a 0 here, but that ends up working out okay, 10, 250. And so if I think of my slope as being negative 10 over 250, that's the same as negative 1 over 25, but much easier to work with here. And so I go down 10, and then right 250. And so that's 100, 250 right here. And so that's where my line needs to go through. And so you guys would take your ruler and draw your line through there. I'll put my line on there as well. And so as I look at this, it's going to go slightly off the picture here, but you can see I want anything that's to the right of this vertical line here. I want anything that's above here, and as far as this last line goes, the y's are less than or equal to that. And so if I want to, I can plug in a point like 0, 0. I would have 0. Whoa, whoa, whoa. I would have 0 is less than or equal to. This would cancel out, so I'd have 0 is less than or equal to 60. That's true, 0 is less than or equal to 60. So I want to shade below this line here. And so if I go back to the green one that I had before, I know I want to shade to the right of this, above this, and below the line that's coming downhill there. And so this is the area right here that is shaded by all of them. So the actual problem itself is the same as we've been doing in the book. You got to graph all 3 inequalities, shade each inequality, and look for the area where they're all shaded. Any ordered pair in this area right here is a possibility of what I could order and still fit into the truck. Remember that we knew we wanted more than 500 bricks, so that's where this inequality came from. I knew I wanted more than 10 bags of sand, so that's where this came from. And I knew that the truck only could fit 3,000 pounds in it. This is the amount of pounds in bricks. This is the amount of pounds in bags of sand. That had to be less than or equal to 3,000. And so this is the graph of all the solutions to this story problem.